Well, hello 1L, and we're going to begin our discussion today about adding and subtracting benchmark fractions. And again, what I mean by benchmark fractions are things that have denominators of 2, 4, or 8. In other words, halves, quarters, and eighths. But before we can get on to adding and subtracting benchmark fractions, we're just going to talk about equivalent fractions because it's important to know how to make fractions have the same denominator in order to add and subtract them, and you'll see why shortly. But first we're just going to talk about fractions that can be written with separate denominator, or the same fraction that can be written with different denominators. So we're going to look at this, and you did a little bit of this in the last lesson. We're going to do a little bit of shading here. So this first fraction that I put says 3 halves, and that's why I've got two different bubbles that have halves in it, because that's an improper fraction, meaning that I have more than one whole. So if I'm going to shade that in, I need to shade in 1, 2, and then 3 halves. Now I'm going to shade in that exactly the same amount on the rest of these things, even though they're divided up into different parts. So we get to shade in this whole one here. We got one whole, and then half of this one. So they all, I hope you agree with me, that they all have the same amount shaded in there. So what do we look at here? How many pieces do we have here? Well, we shaded in 3. 1, 2, 3. In here, how many pieces are shaded in? 1, 2, 3, 4, 5, 6. So that means that we have 6 quarters. And if we take a look at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 eighths. Now here's what I want to point out. I want to point out that we didn't have to draw these out to be able to see it. If you take a look, to go from 2 to 4, I had to times by 2. And so to go from 3 to 6, I also had to times by 2. So whatever we multiplied by to get the denominators to be the same number, we have to multiply the numerators as well. And you can take a look here, 4 to 8 is also times 2, and 6 to 12 is also times 2. And one more thing I'm going to point out, and I'm going to change the color of my pen to do it. If I want to go from this one way over to this one, first of all, I have to figure out how to get from 2 to 8. Well, to get from 2 to 8, I have to multiply by 4. And to go from 3 to 12, well, 3 times 4 is 12. So you can see we can just multiply the top and bottoms by the same number in order to get them to be the same fractions. So let's have a look here. In our example, it says write the following pairs of fractions with the same denominators. So I've got 3 pairs of fractions here, and by pairs I mean the ones that are up and down, and we're going to write them with the same denominators. Now the first thing I said, we have to multiply to get the same denominators, so we're going to make sure that the denominator we get is actually the bigger one. I can multiply this 2 by something to get a 4. And that's what I want to do here. I want to multiply the 2 by something to get a 4. What do I multiply 2 by to get a 4? Well, I multiply it by 2. Now, then I have to multiply the top by the same thing. So I'm going to multiply that by 2, and I get 10. Now, I have an equivalent fraction here. 5 halves is the same as 10 quarters. And now I have a fraction here that has the same denominator as this other fraction. So now we're going to go to the next one, and what do I want to make I've got 2 choices for denominators here. I've got an 8 and a 2, and I can't turn the 8 into a 2 because we want to do it by multiplying, but I can turn a 2 into an 8. So that means down here I have to turn that 2 into an 8. Now how do I turn the 2 into an 8? I multiply by 4. And so on the top, I have to do the same thing. I have to multiply by 4. Now 7 times 4, you can use your calculator for this. 7 times 4 is 28. So now I have 2 fractions. This is exactly the same fraction as the one I started with, the 7 halves, but it has a denominator of 8. And one more here. What are we going to turn our denominator into? Well, I can't turn 8 into 4 because 4 is smaller than 8, but I can go the other direction. I can turn 4 into 8. So if I'm going to turn 4 into 8, I got to figure out how I'm going to do that. What do I multiply by? Well, 2. And I got to do the same thing on the top, multiply by 2. So I've got 10 on top. Now this is an equivalent fraction to 5/4. So now I have the same denominator for those two things. Now you have a worksheet to complete on equivalent fractions.